Welcome students. So in last class we have discussed about resistivity. So we have discussed that the resistivity is the amount of resistance or resistance of the conductor having unit length and unit cross sectional area or area of cross section. Now we have read rho is equal to AR by L, clear, or we can write R is equal to rho L by A. So this formula we have read before. Now let us discuss various conditions here. The first condition is length of conductor is doubled by stretching. The length of conductor is doubled by stretching. That means when we stretch the conductor, we'll stretch the conductor means suppose we will take a rubber band, we'll stretch the rubber band. Stretch the rubber band means its length will increase. As its length will increase, you will find its thickness will decrease. Same thing happens here. When the length becomes double, that means L is equal to 2L. Length becomes double. Area will have or will become 1 by 2A. Area will have. Clear? So at that time, R1 will be how much? New resistance will be rho into 2L into 1 by 2A. It will be how much? 4 rho L by A, or I can write 4R. That means when the length is doubled on stretching, at that time the new resistance of the wire will be 4 times of that old resistance. Is it clear? Next. Next one, next condition, conductor is doubled on itself. Conductor is doubled on itself. It means what? We'll take a conductor, we'll take a wire, just fold the wire. I'll take a wire from middle, I will fold it. This side I will take that side. So when this side will take that side again, you will find the length becomes half, L becomes L by 2 and area becomes 2A. Is it clear? Length becomes L by 2, area becomes 2A. So new resistance R1 will be how much? Rho into L by 2 divided by how much? 2A. It will be 1 by 4 rho L by A. Rho L by A is R. So it will be 1 by 4 into R. That means when the area or when the conductor is doubled on itself, you will always remember that the length becomes half and area of cross section becomes doubled. Now, third condition. Length becomes half by cutting. That means I'll take a wire here, from the middle I'll take cut. That means length becomes half, but area of cross section remains constant. Here length will be L by 2, area remains area same. So new resistance R1 will be rho L by 2 divided by A. It will be half rho L by A. It will be half original resistance R. That means when the conductor is halved by cutting, you will say that the conductor or the resistance of the conductor will be half. Is it clear? Now We have read R is equal to rho L by A. Now let us consider the area of a cross section. If we view sidewise like this, the conductor, if this is a conductor, you will view from one side, you will find the area of cross section of the conductor will be circular. As a result, we can write R is equal to rho L by area of the circle is pi r square. Yes, the area of the circle will be pi r square. That means if the area will or the radius of the circular area will change, obviously the resistance of the conductor will change. Next, we have read that resistivity is the resistance of conductor of unit length and unit area of cross section. Now, this is the quantitative definition of resistivity. We can calculate the resistivity by the definition. But can we find or can we tell the qualitative definition of resistivity? Obviously we can tell. How we can tell? Now resistivity, we can write resistivity is the property of material of conductor which determines the resistance. We can write this is the we can say this is the qualitative definition of resistivity. It means if the conductor is a good conductor, its resistivity is less, resistance is less. If the conductor is a bad conductor, if its resistivity is more, its resistance will be more. If the conductor will be a, or sorry, if the wire or conductor we can say will be an insulator, or wire will be insulator, at that time we can find maximum resistivity will be there. That's why it will offer maximum resistance to the flow of current. As a result, the current will not go through the wire. Is it clear? Okay. Next we'll see, we have read about Ohm's law. In Ohm's law, we have read V is equal to IR. Now many students have asked me question that sir, how we can verify Ohm's law? We have read Ohm's law here. Can we experimentally verify Ohm's law? Obviously we can. Now we will draw a circuit to verify the Ohm's law here. So what we will do? We will take a cell here or battery. You can write cell or battery, whatever you may. This is the positive terminal, this is the negative terminal. Next, we will connect a key here. The key always will be in the positive side, not in the negative side. Next, we will draw or we will write or we will connect an ammeter here. This is the ammeter, plus minus. Next, we'll do or we'll connect a resistance here, any type of resistance, that is called load resistance. It may be any sort of electrical appliance or maybe a wire, that depends on you. Then what you will do? You will connect a voltmeter parallel to the load resistance here. This is plus, this is minus, and here you will connect a rheostat. So that we can control the amount of current flowing through the circuit. Now, when we try to or when we regulate the rheostat or change the value of the current flowing through the conductor by the help of the rheostat, simply the rheostat you can say, or you can take, in your house we are using, or in our house we are using the fan regulator, that is also a rheostat. So if we change the, or when we change the rheostat, there will be corresponding readings of voltmeter and ammeter. That means, suppose rheostat I will put in this position, voltmeter will show how much voltage and ammeter will show how much current. Again I will change the rheostat, voltmeter will show the voltage, ammeter will show the current. Like that you will find the value of voltage and current in different observations. And if you plot the graph between voltage and current, the graph will be a straight line which will be passing through the origin. If the graph will be a straight line, then your experiment will be correct, or experiment is correct, and the slope of this voltage current graph will give the amount of resistance of the conductor, this resistance. You have to find this resistance. Clear? Now, many students have asked me that, sir, what is the difference between voltmeter and ammeter? So we can say voltmeter, this side voltmeter, this side ammeter. We can write it measures voltage or potential difference. Here we can write ammeter, it measures current. Next, it is denoted by V. And it is denoted by A. Clear? Number 3, it is connected in series. And number 3, it is connected in parallel to circuit. Connected in parallel to circuit. And number 4, its internal resistance is high. And its number 4, its internal resistance is low. So these 4 points you will write if you will be asked to write the difference between voltmeter and ammeter. Now, some students are asking that, sir, galvanometer also is connected to see whether current is flowing or not, or galvanometer we can measure the current? No, because galvanometer is an instrument to detect very less amount of current which cannot be measured by the ammeter. Galvanometer is not a measuring device, it is a just detecting device whether the current is flowing or not, and galvanometer also will detect the direction of the flow of current in the circuit. Clear? So I think up to this it is clear to you. You will solve the numerical problems from your book, and any doubt you will message me. Thank you everybody.